Back then we didn't have AliExpress, and from eBay you could buy them in bulk, and it wasn't that painful if you actually fried something. Before many of the hardware building experiments, it was the thought that you need a lot of funding to actually start with it, because you need this and this and this and that, and even if you got those, if they break, and they apparently will, then you will need more money to actually continue your experiments. With Arduinos and repurposed components from radios, the whole electronic building thing became more accessible for us broke students. Thankfully, my friend had some experience. He was disassembling radios, and from the disassembled radios, he got out the different components which he could use then to build stuff.
Most people, they would just have a controller off the shelf, right? What was driving this kind of passion for like, okay, we want to customize and we want to build the perfect thing? Like,
I saw that you really have to do work which you feel on your own skin, you feel on your own life being reflected in a very direct way.
One of the core fundamental things is to figure out, well, how do you connect the modules together, right? How do they fit? I'm guessing it's also important to determine like size. Is that right? Like, because once you set a couple of those key parameters, especially in hardware, you're kind of stuck, right?
Yeah,
like right now,
a couple of years to set these.
Okay.
So you hit the nail on the head with that, because there was one point where me and my founding partner decided on the exact size of the modules. It became written in stone, and we didn't change the external size of the units since then. When we started, not even gloves. You just do it. It's not the smartest thing, but we had to learn these kind of things, of course.
Hello, this is Arseny and welcome back to Product Craft. Today's conversation is very special. I sit down with Kristóf Kerti, co-founder and CEO of Intech Studio, a modular hardware company based in Budapest. What started as two broke high school students cutting up an old Soviet mixing console and experimenting with Arduinos eventually became a global hardware brand. But this isn't a polished overnight success story. We talk about failed crowdfunding campaigns, a $300 marketing budget, building prototypes in a small apartment filled with resin fumes, and the long road from 3D printed cases to injection molding and scaled manufacturing. We also get into what modularity really means, not as a buzzword, but as a system that has to work physically, electrically, and commercially. If you've ever thought about building hardware, launching a product, or turning a side project into a company, this episode is an honest look at what that journey actually involves. Please like, share, and subscribe. I really appreciate all your comments down below. Let's dive in.
So just kind of as a quick recap, you're the CEO of Intech Studio, which is, you guys are based in Hungary, right?
Yes, Hungary, Budapest.
Yeah, and you're manufacturing hardware controllers, essentially, right? For music industry, but also not now beyond the music as well. It's for, right? And so I'm curious, like, how did you guys, what motivated you to start the company?
Partially, it was because of our parents. Me and my founding partner we became friends in high school, and both of our parents were entrepreneurs. Mine became more or less inactive at that time. They had a more or less failing or stopped business. And my friends' parents were also coming to the age of going into retirement. So they weren't that active in business that much around that time. But still, we didn't see a 9-to-5 job in front of us. We both liked music. We both liked technology around music. We were not the best guys to play on instruments when it comes to music, but we were okay enough to help musicians perform on the stage and do the cable management and the mixing and stuff like that. And on this image, we can see a very small, cramped avenue where from our high school there was like a small theater project, and the students were performing some kind of thing.
Mm-hmm.
And all the time at these places, most of the tech available was very obsolete. Most of the things didn't work as they should. And the place to actually help the performance from the tech perspective, so where you are mixing the sound, where you are controlling various aspects of the lighting or the different sounds or music pieces coming in and out throughout the performance, well,
Mm-hmm.
for that we had a very similar scene all the time. But we wanted to take a twist on them and wanted to build something which is more suitable for these cramped spaces. And also we wanted to make music on our own, and I wanted to DJ at different small venues. My friend wanted to play more guitar, stuff like that.
Mm-hmm.
And as we were debating what kind of controllers we should buy or what kind of synthesizers we should buy, we couldn't really decide on what to do, because you can buy controller for a specific purpose usually, and our projects were different every month or every week even. If we were playing together in those projects, we were writing music, for example, in Ableton, a digital audio software, but other times we were just recording into a different software, and we couldn't decide on what kind of hardware should we pick to support all these different workflows.
Mm-hmm.
And also my friend was like an hour bus drive from me, so it was very inconvenient to grab our large controllers to each other's places because they were heavy and bad to carry around. So we
So hold on a second.
yeah
So basically, so you were doing essentially, so you were at college or high school at the time?
we were at high school, and
Uh-huh.
that's where the idea was born to actually build things together.
Got it.
Yeah, that was, I think, not 10 years ago, but 8 years ago.
And so because you were finding basically that the other like controllers in the market, they were too big.
Well, they were too big and too pricey for
Mm.
two high school guys, basically.
Mm-hmm.
It
Okay.
wasn't the most thoughtful process of, okay, let's start a company based on
Mm-hmm.
this, but we just wanted to do it.
Mm.
We have like the 4x4 set of controls, and they can be somehow rearranged and attached together. When this idea started to come together, that's where we thought that, okay, this might be interesting for others as well. So
But
before that,
so let's rewind. Like, so between you guys thinking that, okay, let's try to make a different type of controller, let's make it smaller. Did you have experience building controllers? Did you have hardware experience, or did your friend co-founder have? Like, how do you go from like nothing to creating what we see on the photo?
yeah, thankfully my friend had some experience.
Mm-hmm.
He was disassembling radios, and from the disassembled radios, he got out the different components which he
Mm-hmm.
could use then to build stuff. The interesting thing with us is that DIY electronics became a thing, like Arduinos. When we were at high school or we just started university, Arduinos became things you can actually buy in bulk from eBay.
Mm-hmm.
Back then we didn't have AliExpress. Now
Mm-hmm.
we even have AliExpress. And from eBay, you could buy them in bulk, and it wasn't that painful if you actually fried something.
Mm.
Before many of the hardware building experiments, it was thought that you need a lot of funding to actually start with it, because you need this and this and this and that. And even if you got those, if they break, and they apparently will, then you will need more money to actually continue your experiments. With Arduinos and repurposed components from radios,
Mm-hmm.
the whole electronic building thing became more accessible for us broke students.
And so, okay, so your partner had some experience, like basically disassembling radio parts, but like the Arduino, for example, was it a new thing that neither of you knew how to do before? Like, did you learn it from scratch?
Yeah, he has two older brothers,
Mm-hmm.
and one of his brothers were working at an R&D business at the time,
Mm-hmm.
and his both of his brothers were already at university or ended university, and they had degrees in computer science, or they studied computer science. So my friend, my founding partner, had these guys to look up to learn from, and they eventually got some Arduinos at home and started to build with those. In this process, I was also fiddling around with programming, but
Mm-hmm.
to me, didn't it didn't fit at that time. So I wasn't writing code when I was 16 or 17. He
Mm-hmm.
was, because simply he had a bit different environment and different inspiration to look after. And he had this ability to actually make an LED blink, and I could only just program in C like a terminal, a calculator, which
Mm-hmm.
was fun. But after that, I felt that the next step would be like way too much, and didn't have the patience to stick out. Um, so that's where the
Yeah,
electronic background is coming from.
that's awesome. And so on the photo right now, like, is it one of the first prototypes, one of the first models? What are we looking at exactly?
This photo is an example of us going to the electronic component distributor website, and we saw that, okay, potentiometers cost money, and they cost a lot of money if you want to buy them in bulk. So we decided to buy an old Russian analog mixing console,
Mm-hmm.
and flex it up with the flex. I'm not sure it's in English term, the saw which can cut through metal.
Mm-hmm.
So we cut this up and rewired the whole thing with an Arduino, and got out of this thing some MIDI signals to be the first MIDI controller. The code which was used to make these potentiometers emit actual MIDI
Mm-hmm.
was later used in the modules in the background, which were the first versions of Grid.
There is no Intech Studio yet, right? This
No,
is just you guys just doing things
yeah,
basically for
yeah,
yourself. Yeah, okay.
yeah,
So what happens next?
yeah. After this beast, we identified that there are better shops around, and larger distribution businesses. Like, we learned that there is Mauser.com, TME.eu,
Mm-hmm.
Farnell, DigiKey. So there are places where you can actually buy stuff in bulk. And that was the point where we started to get things in bulk. And yeah, the potentiometers, the faders, and things like that. And we started to take this idea of having a lot of controls, because with this device we also had the issue that it's hard to carry with us because it was large, and we wanted something which can be repurposed from project after project. And that's, I'm not even sure how much time was between these things, but this basically led to this, where we had the first version of magnetic connection between the two boards. If I can zoom in here very badly, these are two wooden little pieces which were first drilled through and then cut in half, and then drilled some more to be holding down a magnet, a rod magnet sideways. And here is a rod magnet, here is a rod magnet, and those two were interconnecting, and the module was able to be powered that way. And this was one of the early experiments and testings if actually this magnetic connection could work.
Like, if I understand correctly, like the fact that the modules that you have now, like essentially are all magnetic and you can like assemble them together, that's one of the, I don't know, identifying unique parts about what you guys do, right? Like, how did this idea was born in a sense? Like, did you want to just experiment with magnets, or was there a particular thing that you were trying to achieve? Like, did you want to connect multiple together?
Okay, so this is basically one of a typical MIDI controller. You have the sliders, you have some buttons, and then more buttons, more encoders. And what we really wanted is to have these kind of control elements like buttons, sliders, and encoders, but in smaller pieces, which can be then put together at a later point. So we wanted first to split this thing up because of the reason that we couldn't say that, okay, this APC 40 controller is the best. There were many other controllers on the market which we could use, but just couldn't decide. And we wanted to pick from all of them some key areas which we liked.
Mm-hmm.
And this led us to the point that we want the typical MIDI controllers to be split up. And then the magnetic idea came as like throughout a brainstorming binge. And okay, what if we take magnets to hold these together? Because we didn't want any additional cables laying around, because back then as musicians or as guys who were active into the music thing, we really didn't like cables because we all the time had some contact issues or something like that. We wanted as low amount of cables as possible.
Mm-hmm.
And from that, we were playing with ideas. I don't even remember what kind of ideas were up on the table, and eventually settled on magnets.
I mean, clearly you guys were really passionate about customizing and making your own things, like right to the point where, I mean, most people, they would just have a controller off the shelf, right? Like they would buy whatever it is that they can afford, and they would just accept sort of that, well, these are the knobs, these are the faders, I'm just going to use it and that's it. Maybe I'm going to buy another one. Like, what was driving this kind of passion for, like, okay, we want to customize and we want to build the perfect thing? Like, where is this coming from?
It's not that great to do manual labor. I was doing some manual labor while I was a student, and getting the money to buy these things for doing music.
Mm-hmm.
I actually enjoyed manual labor and loved it, but the money I got from that, I just couldn't put in any place. And I thought it's a better idea to take that money and fund myself and fund my founding partner to try and build the best thing we can. So yes, we could have bought a thing, and we probably had a hobby, as we could have been musicians that way probably, or I don't know, or at least had a nice hobby. But instead, we wanted to build it ourselves and feel the pain and the joy of building the thing. And it was a very great feeling when it came together and we could actually start to use it.
And is this part kind of coming from the parents, you think? Like, who you mentioned both are entrepreneurs. Like, is it something that sort of you've absorbed when growing up? Kind of this idea of just trying to build things and, making things on your
I think
own?
yes. It's not that I saw my parents build the things. Instead, I saw that you really have to do work which you feel on your own skin, you feel on your own life being reflected in a very direct way, instead of going to be an employee and get a salary in a more or less foreseeable way, or a more or less more stable way. With my head now, I know that there are some very admirable skills needed to be a good employee and to be a good employee, or have a nice place at a multi company or something like that. But at that time, I just only knew that you have to put in the work to achieve something and have a life. If I want to be this black and white kind of guy. And we really wanted to put in the effort into building this stuff so we could probably get a pat on the back or be happy about ourselves that we actually did something with our hands and our minds.
That's awesome. What are we looking at now? These are some of I think these are other brands.
Yes, indeed.
Yeah.
At
This
that
is Rolly,
time,
I think.
yes, indeed. That's the Rolly, and the other one is a bit harder to find. It's Livid Instruments. It's now unfortunately a project which is no longer available. If this project was available at that time, then probably we would have bought this, because it's like the key control elements split together, although not in a fully modular way, but you could do some modular stuff with these as well, with their various products, because here is like ready-made control element sections, and there is a microcontroller behind the whole thing keeping it together. But this project went under, unfortunately. If I know it well, then what the info I could get is that the CEO and the founder became sick, and that's the reason that the project wasn't carried further. But when we decided, or we thought that this kind of modular controller could be useful for others as well, we were already at university. I was into business. What kind of business? Business informatics. And my partner was into electrical engineering. And we both had classes on management, on product something, and basic stuff, but we knew about competitors, that if you are building or doing something, then there will be competitors. And with the thought of building something for others as well, we started to look around and see how others did their product.
So was Rolly around at the time already? Did they exist? Because I know them a little bit. I had at some point, like I had their keyboard, and I know that you can also like stick it together.
Rolly was around. It was very innovative with their interface technology, how you interact with it and how it takes the pressure and makes it into all sorts of digital values.
Mm-hmm.
And it was a project and actually a good looking company at the time, but their magnetic part wasn't around yet, I think, or we didn't see that yet.
Mm-hmm.
And only at a later point, when we also decided to use magnets, looked up Rolly and tried to figure out if actually this magnetic interfacing connection is patented, so we wouldn't get into trouble.
Mm-hmm.
And we did not find. We found some patents on their connection technology, but not much. What we found looking at these products, though, that they were using male and female pins to make their connections.
Mm-hmm.
So on one side, you had like male pins only, and on the other side, you had some female pins for the connection
Mm-hmm.
for a different device. And this resulted in the fact that you can only orient each of the module in a certain way. So you rotate them freely and use them freely. It's not an issue really for the Rolly system because most of their control interfaces are seamlessly put together. And if you look down on such blocks, they are like, you don't really want to rotate them.
Mm-hmm.
But it was a bit of concern basically here on the pallet gear that you only had one orientation to attach the modules, and not really in this scenario, but they updated their products where they put 3 feeders or 3 encoders or like more elements into the aluminum cases. So for us, instead of using female and male connections, we only use male to male connections, so you can actually rotate the modules in any orientation. And also you can slap them together as like a set of 4, because there are no very large male pins which can break down this way.
Can we maybe kind of skip through to one of the current products that you guys already have? Like maybe we can load up several, and we'll go back then to the process. Yeah, so you have a number of controllers right now available, and like they look really cool. Like they have amazing design. For myself as a designer, something that I'm curious about to hear, like how much you can share, is what you guys have learned about like modularity. And I mean, I know it's a very big question. Like probably we can talk for days about it, but like because the idea of creating something that is modular, I mean, it's very attractive, right? Like the premise of modularity is great. Like you can combine pieces together, you create your ultimate systems. Now, I'm sure that there are things that need to be sort of taken care of to enable and make that modular system successful.
Yes.
And I'm curious, like, what are some of those insights that maybe you've learned? It's like, what are some of the foundational things that are important to take care of to actually make a modular system work? Because it's almost like you need to, I mean, in my perspective, you almost need to think ahead on some core things, but at the same time, you can't predict everything, right? I'm just curious to get some of your thoughts on that.
Yeah, probably with a modular project like this, you need time to figure out what people see in your hardware and how that hardware is utilized and what kind of softwares will it be attached to. And modularity on the hardware level is like 50% of the thing. The other part is the software integrations and customization through software, which will enable things for the modular control surface, which is otherwise not doable or not that elegant on other products or other existing solutions. So what we found so far is that we doubled down on the hardware itself to make the hardware like USB protocol compliant in various ways. And this enabled us to add for the modules like a thin layer for hardware customization, like what kind of MIDI data should be there, what kind of keyboard messages should be there, like your mouse or keyboard for sending out macros and stuff like that, how it should send out gamepad messages, all through USB. So once you configured it, no any background running software needed, just the hardware itself. And this enabled us to really focus on the hardware's stability and to make it performant while they are interacting with each other. Because you can build like a large row of controllers, and in that system, the last module which you are using and sends out some kind of data should send its data to all the others and then through the USB. And we really focused for the company's first 5 years or so on the hardware itself, that it is easy to build and reliable on the desk.
Mm-hmm.
And that was something I think we did right, or we have something right. And now comes the software part, because we focused a bit too much maybe on the hardware aspect of it, that you have a great USB MIDI controller, keyboard controller, so these native protocol control things, but to be an efficient control surface for the modern user, you need more than that. You need actual software integrations, and you need actual user workflows or pipelines, use cases shown for the customer to make this modular, everything is possible, a bit more easier to grasp. Because right now we do have a lot of customization options, but most of them, to bring the most out of your system, requires coding, and not very low level, but still it's coding and not just drop down boxes or select fields. And to make our product more approachable and more ready or more finished for the designers or photographers or videographers, we have to make the software part a bit more tailored for exact workflows, exact use cases, because probably a photographer or a videographer won't use all of our different controllers, because the very different control elements are very nice to build a large mixing console for audio, but not really that important to have everything down there for a photographer or a videographer.
One of the important things when you're building a modular system is to figure out how the modules connect with each other. Is that
Yes.
so? Like the protocols and basically how, yeah, like and honestly, I'm curious to look at it. Not necessarily like, obviously you're doing the hardware piece. I feel like it probably would apply to anything modular as well. It's like if you're making anything modular, one of the core fundamental things is to figure out, well, how do you connect the modules together,
Yes.
right? How do they fit? And so, like, I'm guessing it's also important to determine like size. Is
Yes.
that right? Like, because once you set a couple of those key parameters, especially in hardware, you're kind of stuck, right?
Yeah,
Like
that
right
was
now.
a couple of years to set these. So
Okay.
you hit the nail on the head with that, because there was one point where me and my founding partner decided on the exact size of the modules, and it became written in stone basically 4 years ago or so. And we didn't change the external size of the units since then. We only focused on chipping here and there out from the boxes if needed, or shrink down the printed circuit boards by 2 little millimeters or something like that. But the outer dimensions remain the same. And if you are doing something modular, and the modular thing which you often use, and it's so modular that you can actually just apply some strength to it and take it together, take it apart. So there is no extra protective screw or protective something between them. You have to make sure that for the use case people will use this product, it will fulfill its role there. So it won't be just a gimmick, because it's very cool, very interesting. But if it falls apart or the connection is not reliable, then what's the point?
Right. And how do you, this is a great theme to talk about. How do you figure out the use cases for what you need to build? How do you do, like, do you talk to people? Do you do user testing? Do you do your internal, I don't know, discovery? What does that look like to figure out what do you really need to build?
Early on, as we try to build more and more modules, 25 a month or 50 a month, then 100 a month, and so on. And as we built essentially a product from the prototypes, at that time, we released the first version of the configuration software for the modules. And it was equipped with some template parameters. And back then, you had just a couple drop downs to select and choose from. And people started to use our drop downs. We knew what kind of drop downs and the information should be there to be a good audio MIDI controller, because we saw what others were doing and what others had. So we essentially copied those. But as people started to use it, some very experimental but very interesting ideas came from our community of users. So these early adopters were writing like huge emails and Discord messages on what would be nicer, or what would be very cool to have on these kind of controllers. And we essentially got these ideas and gave them a bit of time to distill them. And sometimes we found that if you wait a couple months, then you will have like ideas similar in fundamentality, or it's in its essence, but they are just worded differently. And from those different wordings, we were able to find the sweet spot, what kind of feature we should actually develop. And at that point, we had to decide if this should be included in the firmware and the low level part of the controllers, or somewhere higher up in the configuration part, or something like that. Yeah, that's one part of.
So essentially taking the ideas from the community, right?
Yeah, that was very, very important from the start. And we use that to change around how we are building the software part, or the firmware part of the modules. We also do a lot of internal testing. So we use our own devices for music. We do have like a small pool of people who are working with us making marketing materials, but they are active musicians and they are playing with the devices, use it either in the studio or in live environments, and they come back with feedback on what would be great to have and what would be great to be changed. And it's great to rely on such feedback as well.
I was thinking to maybe go into a bit of the prototyping. Is there the first one that came to the market, or maybe this is some of the behind the scenes process?
So we are building a business. This is how we are building a business in Budapest. We had a small one-person couch and like a ping pong table and my co-founder partner's table. And all the cable there is for an older 3D printer and the computers and stuff like that. We moved together into his apartment and we tried to spend all of our money and all of our time on building the devices because we eventually wanted to create a product which we wanted to sell. We did not know yet how we should do that, but we really knew that okay, this is nice. It's a good feeling to do this. Started to do like the monthly planning and try to figure out how we are on track with different projects, whether it's like getting some new components or testing out a new design. So we were mocking the project management classes or something like that. And at the time, yeah, that's me. So I'm standing on the ping pong table, and this was like building material for an Indiegogo campaign. So this is not how you do an Indiegogo campaign. You have to be more considerate on your target audience, what they expect to see. You can be like a raw kind of guy or very nerdy or this chaotic kind of thing, but we try to position a product like something you can tell your girlfriend about or what to say. So not like a very nerdy product, but instead a product. Not sure how to explain this better.
Like more how you were trying to just describe it and like make it more accessible and understood to the audience about what it would.
Yeah, I think the messy environment would take all the focus away from the product. So anyways,
wait, was it actual, this photo actually was used in the Kickstarter, like, or?
Yeah, so this was a campaign made a long time ago. It was a flexible campaign. It did not succeed. We had a very nice video though, and yeah, we tried to build an Indiegogo campaign in the end, but we had some nice presentational pieces here, and it looked like an Indiegogo campaign more or less, but still it wasn't the thing which clicked with people. We had the marketing budget of like $300 or so. And we did not build an audience to get a following on modular controllers. Before doing this campaign, we actually had a different campaign, which wasn't this big of a...
Why was why did that one did not take off, like based on what you know already today? Because like to me, I personally, I haven't ran Indiegogo or Kickstarter, like, and what you showed there, I mean, this looks good, right? I mean, you have a video, you have a description, you have a product. Because I imagine like many people maybe who have idea about starting something, you know, one of the first things that they would produce would be probably not better than this. So like why did this not work based on what you know today?
So this was the first Indiegogo campaign which we launched. This was a very small project, and it's a Eurorack synthesizer building environment ecosystem, and we actually started to enter Facebook groups and some DIY forums to spread the word about this development. What we had here are basically these sandwichable panels which you can build together and do your own synthesizer prototyping. And this last piece, this last printed circuit board was like a circuit protector, because in this synthesizer ecosystem, you have like very pricey and very expensive modules in a rack. If you are trying to do some prototypes or do your own thing added to this synthesizer environment, you don't want to fry your other expensive modules with the Roche current or something like that. So we made this project to fit somehow onto the first Super Booth we ever visited. So for the Super Booth event, which is in Berlin, Germany every year for synthesizer stuff, audio stuff, things like that. It's like an international expo and a big party. We wanted to do something which is meant for that place to fit in better. We thought that our MIDI controllers are not the best fit on the world for that event. So we made this DIY project to fit in. And for this DIY project, we essentially had an okay marketing effort, doing our things in Facebook groups and synthesizer forums, and people supported it, and it got us the 3,000 plus USD. And we used the people of this campaign, the 52 backers and the newsletter subscribers, as we treated these leads more or less equal to those customers who might buy Grid as well, a modular controller project. But there wasn't much of an overlap between the two communities. And basically we should have built an entirely different following for this project to make it more successful.
I see. So basically, you didn't have the audience yet. Is it so? These days, how important is it to build up like the following and the brand like on social media? Is it a big part of the? Is it?
I think it's everything.
It's everything.
You do need a good product. A good product can sell itself, but it won't sell itself because if nobody knows about it, then it can't sell itself. A good product can enable a competent marketing or product team to advertise that product. It's much easier to actually do a product demonstration with a working and great product instead of faking it together.
Yeah.
If there is only one or two people in the room, then okay, you can say that this is just a demo and don't look at that part. It's broken, but it's okay. We will work that out. But focus on this one. If there is only a couple eyes on the project, then you can slip with this method, I think. But if there are many random people on the internet who don't have the time to really get into the bottom of your project and your personality and brand and everything, for those people, you actually need to do something cool and show them something cool, which is interesting to them.
Mm-hmm.
So I think social media, or not really social media, it can be a very nice newsletter, or it can be a very nice blog or whatever, but some sort of medium and some sort of audience is crucial to actually run a successful business or campaign when it comes to crowdfunding.
Are you generally naturally inclined to do the social media yourself, or your partner does, or is this something that you had to hire people for?
Everything the like on this picture where I'm standing on the ping pong table, there I was the social media manager and everything together. I actually knew that we need marketing, and I was the guy who tried everything which is not hardcore engineering to keep the project afloat. So I was the finance or the other part of the typical engineering role, or so to say. Of course, we collaborated a lot on the different social projects or social media projects with my founding partner, but I tried to fill that role. And some of them didn't come easy, but I use those learnings and those thoughts which I had when I was doing YouTube videos for tutorials or photo shoots for the first Indiegogo campaigns or stuff like that, where I had to do them to actually try out and learn Photoshop and use Lightroom for raw image processing. I actually got a mirrorless camera to shoot the videos and learned how cameras work and how important lighting is.
Mm-hmm.
Without these tasks and this marketing role, I think we wouldn't do the opening towards designers or photographers or videographers. I am not by any means a guy who could stand in photography business or videography business without a lot of hours of practice, but I think I can make such people happier by building them a product.
Mm-hmm.
And for this hunch or this feeling, these kind of social media work pieces help me.
Are most of the clients these days in Europe or in the United States, or it's a combined?
Most of the buyers are in the United States, so it's over 50%. The rest of it is mostly Western Europe, and then some from Japan, South Korea, and some from China.
Cool. What do we see here in the image?
Yeah, on this image, when we were in our apartment with my founding partner, this was actually the point where we decided to look after our first office space, because this was a 3D printer, which was a resin 3D printer, and actually behind the door is the kitchen, and what you can't see on this image is my room, and it's not that great to sleep in this smell of UV resin and hear the machine going all night long to print out the first cases.
I heard it's
This,
toxic.
yeah, we got from that for a couple years, I think. Eventually, we built out this fume exhaust in our offices, so we take care of our employees, and eventually we took care of ourselves. But when we started, not even gloves. You just do it. It's not the smartest thing, but we had to learn these kind of things, of course.
Yeah. And what
After
year is
this,
this?
what year? Think this is 2019,
Okay.
so 6 years ago,
Okay.
because this printer was our first purchase when we actually got our first venture capital investment.
Mm.
So this was after a failed Indiegogo campaign, but a successful expo visit at Superboost 2018. And this was the point where we still believed in our project that
Mhm.
we should do this, but we told ourselves that okay, we don't have neither the friends or the family or anything around us to fund the project further. So either we convince the investor that it's an okay project, or
Mhm.
we stop with it and we just stash the experience which we learned throughout the whole thing.
And did you find like an angel investor, or was it like a VC company, or?
It was a VC. A lot of things came together, I think. The first good timing was, which we talked about, are the Arduinos, I think,
Mhm.
which were available for my friend to start with experimenting. And the second thing, as we are talking, is the investment and venture capital environment in Hungary. Our investor, High Ventures, just I don't think it just started, but their incubation program was very fresh, and they partnered with universities, and they started to make the entrepreneur market or entrepreneur environment something
Mhm.
in Hungary, because there are some Hungarian projects which became internationally known and great projects. Probably heard about Shaper 3D. It's
Mm-mm.
a it's a CAD software. Then there is Craft Docs. That's another interesting application thing. I think there are some hardware projects as well, but I can't name any now. And I think that shows that the Hungarian startup culture or startup business environment is not a not a big thing. And
Mhm.
this High Ventures had on their About Us page that they want to create an environment in Hungary where entrepreneurial mindset can be rewarded and it should be supported, and probably partly because of these words and because we needed money, did our application with them.
And so, was it I don't know, is it private information or is it like a public round? Like, I'm kind of curious, like, what is the magnitude of how much money one needs to be able to take, to fund a project like this, like for hardware?
This is an interesting question because when we went to the investor and when the first Grid Modular MIDI controller campaign was shot and these white boxes are present and already the modularity works, we didn't have any software for them. We did have some hack together, but nothing serious. So for these products, we actually invested into our work 3 million forints, which is, I think, 10K US dollars.
Mm-hmm.
So from 10,000 and probably around 5,000 hours or so, maybe
Mhm.
more. I think 8,000 hours of project time and 10K USD. That was the point where we went to the venture capitalist firm.
But basically, it sounds like if somebody has, I don't know, the prices in Hungary could be different also from US, but it sounds like if somebody has, I don't know, 20, 30, $40,000, they could potentially, you know, try building a couple of things, at least for like prototyping. Basically, it's like it's not millions of dollars that you need
No,
today. It's
no,
it's like tens of thousands of dollars to because there is a perception if you're going to be building hardware, you need a ton of money. I mean, $20,000 is a lot of money, but at the same time, I mean, it's different from $10 million.
yeah.
Yeah.
Also define hardware. So what I'm talking about here with the first Indiegogo campaign, these are functional working prototypes,
Mm-hmm.
but not production ready hardware.
Mm-hmm.
We were able to get funding for these working prototypes. I think if we didn't have these, we wouldn't get the money from the venture capitalist firm.
Mm-hmm.
So yeah, it's thing for like an MVP, but not even minimum viable product, but minimum viable prototype.
Mm-hmm.
You can go with K, something like that, depending on how big the physical product is.
Mm-hmm.
We are in a very lucky situation where our products are small, like the palm of your hand, basically.
Mm-hmm.
So because of this small size, it's cheap to import and ship it from China, as we have been prototyping our printed circuit boards in China. And that's a big aspect of it. You can buy a 3D printer to build the enclosure, and that's great. Many DIY projects only have a 3D printed base, and the 3D printing technology, this is the first lucky thing I think we have now, is accessible. So when we started the project, we saw that you can buy for a couple $100 a 3D printer. They were very bad compared to the 3D printers available nowadays. You had to build them yourself and hack them together. There was not much documentation and knowledge yet online, but 3D printing became accessible, and it became a hobby for many to do some home appliances with it or stuff like that.
Yeah.
Yeah, China became very good at creating printed circuit boards, and China has now 2-3 companies like PCBWay or GLC PCB who are very great in rapid prototyping. You just go to their website, upload the files they need, and they will do your printed circuit board. For that to work, you will need an electrical engineer, I don't know, hobby or friend or someone. But it's also a skill which can be picked up, although it's a hard skill, but yeah, doable.
Do AI models these days, can they create designs for like electrical boards? I don't know anything about it, by the way, so I'm just like totally
I think if you have like an electronic like schematics, like a sheet, a simple paper which describes what kind of electrical component is connected to what to do essentially something. So if you can draw out the physics of the device, then probably based on those drawings, which become essentially an electrical specification, I think an AI model could, like in a MCP style of way, or how it's a trending topic now, how AI models can take over your software or something like that. Based on such drawings and schematics, I think the circuit board design process can be done with the help of AI. If it can do things from the zero, yeah, I think probably there is some kind of AI model which can do
But better to have a friend who is an electrical engineer.
I think the same can be said about software development, is that if you have very little knowledge about the area, how it should look like or how it should work, then if there is a mistake made by the AI, it's very hard to debug and see where it went sideways.
Yeah, you mentioned like in a earlier in the very beginning that you have like this love-hate relationship with the project. Can you expand on that?
Yeah, right now I really love the project, and it's a cool project. It's hard to actually build a company around the project. And what I referred to as a love-hate relationship is more like to my role as a CEO, or my role in the everyday life, how I should tackle tasks, and how I should split my focus between the project or the product itself and the other side, like CEO stuff, people management, and investor relations, stuff like that. And I tend to find joy in both. I like product more a bit, so I like to get lost in cool ideas and prototyping stuff. But yeah, I got this got this card to be a CEO now, and have to be cautious how I am splitting my time between tasks and responsibilities. Probably that's my love-hate relationship with the thing, because sometimes it can feel like a burden, although I did put myself into this position. So if I feel that way, I should nudge myself a bit to move out of this feeling and find back to the things I like and love about it. That's what I mentioned under that.
No, it's thanks for sharing. It's I mean, for me personally as well, like I used to run a product design studio in San Francisco for a number of years. I love design, the process of creation, but like business development part of that is something that I was not necessarily enjoying, and it's like trying to figure out how to, but without that, the business cannot exist. And so trying to figure out how to recognize your strengths and then on time find ways to, perhaps get help for things that you don't enjoy or you don't love doing as much, or you're just simply not the best at. That is an important thing in my personal experience as well, because otherwise it can, take too much energy and just drain. In my experience, as you get older, you kind of start to better recognize your strengths and weaknesses, like kind of being a bit more honest with yourself.
We talked about you asked if how social media or marketing was earlier on. And I mentioned that I did a lot of marketing myself, but I knew that I'm not the best guy for that. So eventually my first thing was to start build out a small marketing team and get help with content and production and things like that, because I had other areas to focus on, and there were people who were just very into the marketing aspect of this business. What you can see here is some of the team members of that small manufacturing assembly, where we employed like 10 people coming in random times when they didn't have university or some kind of classes to come in and actually put the little electrical components onto the boards, which we later on soldered together. So this was like the first version of an assembly line for in the studio building products. This was downstairs, the packaging station. These were the main instruments. Again, the 3D printers. This is the 3D printer, which was previously seen here. So with this one, we moved there. And yeah, this was our first normal office space. We had the beer in the fridge, and we had even like this lower space where we made some very loud and very noisy and very dirty machining tasks. So that it was another space we used. This was the office after that. This was a much bigger space, and we had like this U-shaped assembly section. And at this point, we still did a lot of things by hand. So we ordered the main circuit boards from China without any assembly. So we did all the electrical soldering in-house, and we figured it out ourselves to get experience about the proper design for manufacturing process, how the different modules should be engineered to be efficiently built together. So this was a very interesting time for us to get from a prototype to a product, which cost a lot more money than 10 to K, which we discussed earlier. Some more machines and some testing for the base of the modules. From the 3D printing, which was very great for prototyping, we actually had like 60 different case design versions until the point we settled on one design, which was eventually injection molded. So we had like 60 different versions of the different little settings for the base up until the point we arrived to the latest ones. I even have, I think, here like an image. Yeah, like these ones.
So this is injection molding?
I'm actually not sure, but this texture is a bit interesting, but this is the shape of it. This is how it should look like, I think. But yeah, there were a lot of iterations upon the other point we got to injection molding. From 2019 all the way to 2023 October, we did 3D printing for the module houses. So the first couple thousand products were sold with 3D printed houses. I don't have here I only have it on an image, but the cool thing about these injection molded houses is that they were then routed around with a CNC router. So the injection molding itself gave us a very, very bad texture finish. So in the end, we decided to also mill it down like a very tiny amount to get a better finished result. So yeah, it was a long time until we got to injection molding. This is, I think, also interesting. We really liked this solution to assemble the interface panel with the main circuit board. So I have here a module, I think. So here on the side are the interface boards, the logo pins, and that should be somehow connected to the main port. And we used these flexible PCBs first, and with this custom a little socket to build together the modules. But I think it's already visible that this is a very weak connection, and it eventually tires out, especially that you had to flip this side over next to this one, this black section, and yeah, that could cause like cuts within the material and things like that. So even though it was a method to assemble the product, it wasn't the most efficient one. And after a lot of prototyping, we eventually got to these little spring-loaded battery connectors which are interacting with the main printed circuit board, and the whole thing became a press fit thing. This part, going from design to manufacturing, took us a lot of money and a lot of time. So this is why I asked earlier, back to your question, that how much money it takes to get a product in the end. It can cost a lot, even a small piece. But our end result is cool because we don't have any gluing included. Everything is press fit, and you only need a screwdriver to assemble it, basically. So that's a neat thing. Some more images about the vision. What we try to do here, and this applies to many of our different controllers, that we try to repurpose the printed circuit boards between the different module versions. So for example, if I have like this won't be the best example, but I have here two modules, then it's very cool if internally the printed circuit board can be reused between the two. And for example, we reused for a long time the button modules. This is the older series 2 button module. The button modules printed circuit board with the module with potentiometers. The buttons and the potentiometers shared the same footprint for the component, so we could just make this adjustment for the printed circuit boards to be able to order one type of circuit board, but use the one type for two different products. With a modular device, it's also an issue that you often have to pay premium for many low quantity devices or materials which you want to test out. And it's a cool cost saving thing to try to repurpose some of the key components. And here on this image, this is the vision module with the screen, and it's sharing the circuit board with the Tech2 2 large knob controller. So with the latest module, we also tried to use this method to actually reuse most of the design across the modules. Here, for example,
really cool.
Here this is a small perforation. You can see my mouse, right? So this part is like a little perforation where you can essentially break out this section, and behind this section is the place for the knob itself, the large knob. If I come here, so here this is a broken out part, and the large rotary, it can be soldered here, and the screen is then on the next side. So we try to do such tricks hardware wise to cut costs and make most of our designs reusable this way.
Yeah. All right. Well, Kristof, thank you for like giving a glimpse into the behind the scenes of what's going on at your company. Like, I think it's for me personally, I'm not an expert in hardware building. I am fascinated with what you guys are doing. I think for a lot of people, it's going to be interesting to just see behind the scenes of like what it actually takes and the amount of work. I can totally see that. Yeah, just like how every single step of the way, it's a lot of work, and I wish you guys the most success on this.
Yeah, thank you very much.
Yeah.
I hope I could really give a glimpse into what we are working. I try to be open about it, both the hurdles and the good parts. And yeah, I think what my experience is that I got lucky, got a great friend who I was able to start this company with, and yeah, I had someone who I could rely on to build out eventually a hardware product.
Mm-hmm.
I think it's a nice to have some kind of technological curiosity when somebody builds a hardware business, and not just rely on an external or just rely on your partner. I think even some programming knowledge or software development knowledge or any sort of engineering knowledge could help, even though if you are not the executor on the project in that area. So I tried to learn a lot from my founding partner, who was the mechanical engineer, the electrical engineer, the whole engineer behind the project. And I think it helped our relationship and how we were able to shape this project and company together. The fact that I try to listen to him as an engineer, because it's sometimes hard to talk with engineers or understand their underlying problem or something like that. And I have seen examples where the engineer lost its temper or lost its will to explain and just said it can be done, or said something very vague about a problem or some part of a project. It didn't happen with me, fortunately, but I have heard and seen such cases. So to avoid these,
When engineers said that it can't be done.
yeah, or with an enormous timeline or something, the engineer started to talk like a businessman, or how to say this without much trash talking. I think this valley between the engineer and the designer, or the engineer or the business guy, really exists, and it's hard to sometimes communicate over the two from the two people's perspective.
Is there a trick to like, or what advice would you give to better communicate with engineers in general, so that to like ensure the maximum chance for success?
I think, yeah, be patient. Be patient with engineers. Let them talk, but not too much. and get to analogies and metaphors, because I think the engineers tend to think of themselves as smart guys, and sometimes the smartest in the room. And if they are that smart, then they really should try to make their point understandable to you if you are not in that area. And for that, I think some analogies and metaphors can come in handy.
That's a great advice. Yeah, I personally I love the use of metaphors. Actually, in my in design work, I work a lot in kind of complicated domains, like biotech or healthcare that I don't really have any idea about because I'm not a clinician or a scientist. But one of the ways to figure out how to do that, what I arrived to is, like finding the right metaphor is incredibly useful, because when you find it, all of a sudden it can decrease the cognitive load to process
Yes.
things. You're like, all of a sudden you're operating in a much simpler environment. And I don't know, it's kind of magic, but then it's sort of when you expand it to the actual problem that you're solving, more often than not, things still kind of tend to connect and make sense. So finding the metaphors is actually one of the big things that I like to talk about, like with new designers who are like stepping in, but I think not just designers, it can anyone who is working in a field that is not trivial or new. Finding that right metaphor is key, and sometimes it doesn't match exactly. You need to be aware of the two, but yeah, that's a good advice.
Yeah.
Well, thank you so much, Kristof. Where should people? I'm going to include the link to the website in the description. Intech Studio. Where else can people find you if they wanted to reach out? And maybe, do you want to reach out?
I'm okay with it. I think LinkedIn can work.
All right. Well, once again, thank you so much for coming on. Bye bye.
Bye bye.